Hello and welcome back. We are starting chapter 2 today, and we're going to be talking about frequency distributions. And this is take 2, that's why this part's already filled in. Before I get into these definitions here, all of these numbers and everything that you see are going to be based on this distribution right here. And so let's start with the definition. Frequency distribution shows how data are partitioned among several categories. We call these classes. That says classes, believe it or not. By listing the categories along with the number, the frequency of the data values in each of them. So this is actually a nice organized frequency distribution table of this data down here. This is in your textbook, and it didn't copy all that well, but you can see that these numbers here, and all these numbers here are represented up here. So let's start with the lower class limits. That's the lower class limits, the 50, 70, 90, 110, 130. And you can see there are 6 classes here. 1, 2, 3, 4, 5, pardon me. 5 classes here. The upper class boundaries are the upper boundaries on the edge here. So that's 69, 89, 109, and so on. The class boundaries, so let me explain this a little bit. Do you see that there's a gap between the 69 and the 70? A way to bridge that gap is to move down just a half a tick. So if I go down 1/2 from here, that's at 49.5, and if I go up 1/2 here, I'm at 69.5. You can see here that if I go down a half, I'm 69.5 again. So the end boundary here is the beginning boundary here, all the way down. And you can see how I'm doing that. Now, if there was a decimal on these, then you would need to add and subtract 0.05. But right now there's no decimal, so we're going 1 decimal out. If there was already a decimal, we would go 2 decimals out. 2 decimals out, we would have to go 3 out, and so on. The class midpoints are basically, I'm taking the upper boundary, class limit, and the lower class limit, and I'm adding them up and dividing by 2. So if you take 50 plus 69 divided by 2, 50 plus 69 equals, 50 plus 69 equals divided by 2, and there's where the 59.5 comes from. And so I did that for each class I went through. And this became 59.5. Class width. Now this gets a little confusing. The class width is going to be the difference between the lower class boundaries. So 70 minus 50 is your 20. That's the class width. And you can see it's consistent. 90 minus 70, 110 minus 90, and so on. Some students, they try to do class width by going 69 minus 50. That'll give you 19. That is not the class width. It's got to be between the lower boundaries of the classes. So I'm going to give you a minute as we flip to this next page here. Here we have the heights in inches of commonly grown herbs are shown. Organize them into a frequency distribution table with 6 classes. We'll get to that in just a second. I'm going to give you a minute, and I want you to put the data into your calculator. Here's how you do that. You hit Stat, and I want to edit a table. So you can see 18, 20, and so on. So I'll give you a minute to do that. I think I messed one up down here. Oh, it looks like we're good. Now what I want to show you how to do is how to organize this list. I'm going to quit out of that, second quit. Notice anytime I want to activate the blue on top, I have to hit the second button, the blue button, to activate that. Now, what I want to do is I want to, excuse me, I want to hit Stat again, and I want to sort it ascending, meaning from smallest to biggest number. So I'm going to hit 2, and I want to specifically sort list 1, which is above the number 1 on my calculator. And notice it's blue, so in order to activate that, I have to hit the blue, second L1, and I hit enter. And what that does very nicely for me is that goes into, as I go into here, it lists them and puts all these in order for me, which is very convenient for me. And we'll see why we're doing that here in just a minute. So hopefully you've put all of your data in there. There should be, now notice there's 1, 2, 3, 4, 5, 6, 7 across, and 3 down. That's 7 times 3, which is 21, minus 2. So you'll notice I have 19 pieces of data. Oh, there's that mistake that I had. Clear that. Notice I have 19 pieces of data. That's one way to double check that. All right, we're going to start out by trying to make our table. We're going to find the class width first, and that is going to be, so that's going to be the max minus the min divided by the number of classes. So in this case, I can look back at my calculator. The largest number is 36. The smallest number is 7. And the number of classes is 6. Let's see what we get. Now, I got 4.83 about, and what we're going to always do is round up. So our class width is going to be 5. All right, so here's how this is going to work. I'm going to make a table, and we're going to answer all of these questions. I'm just going to do it in one big table. This is the height. This is the frequency. Now my lower limit is going to start with 7. This is one class. Next up, what I'm going to excuse me, what I'm going to do is I'm going to add 5, my class height, or class width, I should say. So that's going to be 12. And then I'm going to add 5 again. So hopefully that's clear on how I'm doing that. So these are my lower class limits. Now the upper ones are going to be easy. I'm just going to subtract 1 from there. Subtract 1 from there. Notice I'm adding 5 as well. 11 plus 5 plus 5 plus 5 and so on. So this will go to 21. This will go to 26. Now I'm just going to add 5 to that. Adding 5 there gives me 31. Or I could see that's 1 less there. And then adding another 5 here is going to give me 36. So there are my classes. Now we're going to come back. So we've just identified our classes. We found the lower limits first by adding 5. Upper limits by subtracting 1. And so on. We've identified our classes. Here we are. Now we're going to do the frequency. I'm going to go back into my list. And I want to know how many of the heights are between 7 and 11. So I'm looking here. 1, looks like 2 of them are. Now how many of them are between 12 and 16? So there's 1, 2, 3, 4, 5. Ooh. 5 it looks like. Let me count it again. 1, 2, 3, 4, 5 it looks like to me. Between 17 and 21, let's scroll up a little bit. 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like 9. Hopefully you're counting along with me with your calculator. Between 22 and 31, so 1, 2, looks like 2. And between 27 and 31, we have none. And then we have 1, it looks like that's between 32 and 36, which is 36. And there it is. There's our frequency distribution table. Hopefully you could recreate that if you needed to. All right. Now we have some variations here. A variation of a basic frequency distribution, which is what we just created, is called a relative frequency distribution. This is sometimes called a percent frequency. And you will see why here in just a moment. Now if I go back here, I'm going to notice between 7 and 11 I have 2 out of a total. Remember there were 19 total. Oh, it's not based on this data though. Sorry. This next exercise is going to be based on the first page data, so it's going to be here. And there are a total of 78. The way we get that is we add up the frequencies. So 2 plus 33 plus 35 plus 7 plus 1. And there's 78. So again, what I'm about to do is going to be based on this data here, not the previous data that we just went through. So here we are. And I will flip back. So to find, so we have the frequency. I'm going to cheat here. 233. And so the relative frequency, another box here. Frequency is going to be here. So for the first one, so for the 50 to 69, there are 2 out of 78. 2 divided by 78. And to turn that into a percent, I'm going to go times 100. So that's going to be about 2.56%. So for the next one, I'm going to go 33 over 78. Times 100. That's going to be 42.31%. And you're going to do that with each of these. So next up is going to be 35 over 78, 7 over 78, and 1 over 78. To save time with the video, I'm just going to write them in. This is 44.9%. This is 9.0%. You, of course, should be verifying all of these with your calculator. Don't trust me. 1.3%. And there's our relative frequency distribution table. The next type is called a cumulative. frequency distribution. This one's going to be a little different. I have this one already typed up here. Again, it's based on the same information. This table is exactly, where is it? This table here. I recopied it in the notes. And the way this works is, notice that this is set up a little differently. How many of these are less than 70? Here's 70. There's only 2 that are less than 70. How many are less than 90? Well, that's going to be 33 plus 2, or 35. You don't need to write that in, but I just wanted to show you where I got that from. How many are less than 110? Here's 110. How many are less? That's going to be 35 plus 33 plus 2, and that is 70. So now it's going to be the 70 plus 7, less than 130. Then it's the 77 plus 1, which is the 78. And we should always end with whatever we had for our denominator here. That should always be a total cumulative frequency distribution. The graph of these are really cool. It's called an ogive. Next up. So here's our information. I want to introduce the idea of a normal distribution. That's going to be really big as we're running into things later in the semester. And the idea is there are very few on the end. Most of the good data is in the middle. And it actually forms a shape that looks like this. This is called a bell curve. And that's going to be very, very important. So you can see there's very little data. And when we say data, I actually mean the area underneath. And we'll talk more about that later. That's not for this chapter. There's very little data over here, but most of it's in the middle like that. Hope that helped.